That's my scientific way of explaining everything. Cool. Well, we got quite a few people here, and it's 5 after, so we will dive into the class today. So one of the big things, if you do not know, if you are new here, we do have a GitHub account. Oh, look, I can triple. Boom. We have a GitHub account, github.com/silicondojo, online-classes. If you come here, basically these are all the classes, and these are all the material for these different classes, labs, workbooks, that type of thing. I recommend you come to this every time before we start a class. Generally, there's going to be a workbook and a lab book. Today, we basically just have a workbook, but you can come on, you can click on the specific class. So this will be the same name as the class on Meetup, and you can come here, and we have the code, and today we have the PDF. So we have a lab book PDF file. I would highly recommend that you download and print this out. So this is going to be the projects that we're going to be doing today. It'll be the code, just in the code format. So you can sit there and tippy-tap type out the code for yourself. Because again, do remember, you do not become a technology professional by sitting there and listening. You become a technology professional by doing the damn work. When I talk about single quotation marks and double quotation marks, if you have a PTSD reaction to that, then you know you're a technology professional. If you're like, oh, wow, what's the problem? Then you don't know. Also, just so you know, there is the Eli Computer Guy YouTube channel. So I have one camera here for Zoom and one camera here for YouTube. And so I am actually recording this in 4K for YouTube. And we have our previous classes up. Our first 4K class was TCP/IP, but these classes will be up so you can watch them in the future, and you might actually be able to see the screen a little bit better. Also, I do have the Eli Etherton. I have my LinkedIn profile. If you want to, I don't know, friend me or whatever the hell it is on LinkedIn. I talk about some stuff there that I don't talk about in the rest of the world. So that all exists. Let's see, just scroll through this really quickly. So Silicon Dojo, the concept here is authority gatekeeper-less free to the end-user hands-on technology education that empowers you to do whatever the hell it is that you want to do. Basically, my idea is that technology education should be as accessible as water, right? Education empowers people pay more taxes, ergo, we should educate more people. I don't know. It's my Aspie logic going on. I will say it is free to the end user, but that doesn't mean it's actually free. We have no sponsors because Cisco and Intel don't give a damn about what I'm doing. So if you would like to throw a couple of dollars into donorbox.org/ETCG, that would be absolutely lovely. So basically this is crowdfunded. If you have a question at any time, you can raise your hand in Zoom, wherever that thing is, and then I can answer your question. Basically, if you raise your hand in Zoom, I will go along, I look at the screen. When I have a moment, I will ask you the question. Makes life easier. Don't actually physically raise your hand. It is adorable, but I won't see it. Let's see, copyright. All the material that I've created here you can basically use for commercial purposes. If you want to use this in order to create a program in Mogadishu to teach kids there how to become technology professionals and you want to charge them $10 a class, good for you. That's fine. Tippy tap or die again at the end of this. We're going to have all these labs. I would recommend, if you want to be a technology professional, to actually do the labs. What do I know? I've only been doing this since 1996. Anyways, again, with being a technology professional, it's experience. Basically, fixing your grandma's computer is more or less just like fixing a CEO's computer. The more you fix computers or do whatever, the better and easier it's going to be. If you just sit back and try to learn this crap by osmosis, I don't know, might work for you. You will be the first. Extra help, w3schools.com is absolutely great, and ChatGPT. Again, ChatGPT is not artificial intelligence. Do not call it artificial intelligence in my classroom, but it doesn't mean it's not a damn good piece of functionality, especially for coding. If you're trying to figure out why your SQL statement doesn't work, throw it into ChatGPT and it'll probably tell you why. Let's see here, standardization. So we use VScode with the default settings. Again, I do not care what IDE you use, we use standardization. So, especially during these lab type things, if you're having a problem, we can do a screen share and I can see what the hell you're doing. Again, you can use Notepad++, and I will do my best to troubleshoot your problems, but Anyways, let's see, material, we did that. Trolls, we haven't had a troll problem for a while. And typology, just to talk about for 1 second. So I did that TCP/IP class a couple days ago, last week, I guess. And during it, I talked about typology. Typology instead of topology, Topolgy. I just want to take a second to talk about this. Again, one of the things you have to be thinking about with any instructor that you're going to be listening to, anybody that's going to be teaching you, is what the hell is their bias, what is their lived experience, and the whole 9 yards. They are going to teach you what they consider best off of whatever the hell's going through their head. I think this is an interesting example. So I brought up the word typology when talking about topologies, essentially, for networks, right? A ring, a bus, or a star. Is it a typology or a topology? Anyways, I got a lot of insults on YouTube. Typology doesn't mean anything. It's topology, you dumbass. Which again, it's amazing how much insults you can get for one theoretical mistake out of a 3-hour class. But what was curious about this is I actually went back and did a little bit of research. Because I was like, that's weird. That's weird. Is it typology? Is it topology? Was I talking out my ass? Was I remembering something from the ether or whatever? And that actually is the case. Again, I got my MCSE back in 2000. And in 2000, the term typology was actually used back then. If you go and you do some Google searching and you put in time restriction and you do pre-2010, you will actually see Cisco documentation talking about typology. And the reason for that is in the modern world, everything uses Ethernet. Not really. As far as you're concerned, everything uses Ethernet, right? So anyways, in an Ethernet world, you're all using switches and routers and hosts and TCP/IP and MAC addresses and hubs, well, not hubs, all that kind of stuff, right? It's the exact same type of equipment. And so whether you have a ring topology or you have a star topology or you have a bus theoretical topology, they're all going to be using the exact same type of equipment. So therefore, when you're talking about this, it'll be topology. Back in 2000, when I was learning this horse crap, these were actually used different types of equipment. So a token ring network basically had its own protocols, its own equipment. A token ring network did not work with an Ethernet network. If you had a bus network, you had these things called vampire taps. I've seen a vampire tap once in my life. Anyways, you had these things called vampire taps. And so anyways, so why I think they used to use the term typology is because typology actually groups things together as a type. So now they say it's normally used in linguistics, you know, the social sciences, a typology of a people. But that's the thing, is if all of this was using token ring equipment, and all of this was using bus equipment, and all of this was using Ethernet equipment, then it makes much more sense that back in the day they used the word typology instead of topology. And that's basically, I guess, a very long way to say things change in the technology world. And again, it's something to keep in mind when I talk about things. Stuff has changed. Stuff has changed in 30 years. I know it's a shock. It's a shock to some people. But anyway, so sometimes I say some things. Maybe I'm wrong. Maybe it's old. I don't know. Oh, let's see here. Try restarting Zoom. Well, everybody else seems to be doing fine. So anyways, that is that. So we have our labs today. So the idea with the labs today is basically I have created these labs for you folks to try to replicate at home. Try. We'll see how well this does, with the idea being that you can then modify. Again, these are labs that actually do something that might actually be useful for you in the real world. I try to give you the base level of what makes it work, and then you can try to modify it and customize it and do something else with it, right? One of the big things, again, to being a technology professional is that your bosses are going to want you to solve problems, right? Especially in the technology world, when you start looking at this kind of thing, it is very hard to be micromanaged to do this type of work, right? Having somebody stare over your shoulder and tell you exactly how to do every damn function is just a misery for everybody involved. Your bosses are going to want to tell you what the problem kind of sort of is, and then they want you to come back with the problem solved, right? Basically, they may go through an audit, right? You might need to fix the naming convention, you may need to do something like that, but they want to audit your code. They don't want to have to be over your shoulder and basically tell you exactly what to do. So one of the things that you need to do, again, if you really want to be a technology professional, is start going out there and just try to start finding problems, any problem at all, and see if you can find a solution for it. Again, one of the things I like about networking type apps is basically this is a good way to deal with dynamic information. So dynamic information or dynamic data is data that will be changing. It will be changing itself based off of real world conditions, and then you can parse and then you can do if-else conditional statements based off of that data to make different kinds of things happen. So I like using networking type stuff. Once again, it gives you that dynamic real-world experience there. I was interviewing a CEO of a development company that has done very well. He had done very well up until that point. It's done even better now. Years ago, actually, 7 years ago. Anyway, so I was there, I was talking to him, and again, coming from the sysadmin world, we had our MCSEs and our CCNAs and that type of thing for certification. So I asked, like, well, look, you know, you're the CEO, you're the owner of this company. What certifications do you look for as a development company? And literally, the guy looked at me and said none. I was like, what? And basically what he said, this is something to think about, right? Is he said, if you come to me with a whole pile of certifications, that shows me what you think is important. And I don't give a damn about certifications. I care about solving problems. Basically, he said, you come to me with a nice little portfolio of the things that you have created. He is very interested because that shows you have seen problems, you have tried to come up with a solution for the problem, and you have tried to implement the problem. Again, naming conventions, other stuff, those might be some issues there, but it shows that you have that basic skill set. If you come to him with all kinds of certifications for all these programming languages, you know, basically goes, oh, you think taking a test is important. So anyways, something to consider there. So we've got, I don't know how many things we got. 1, 2, 3, 4, 5, 6, and 7 labs today. We'll see how this goes. So at this point in time, if you've been following along at home, if you've been taking the classes, we have learned Python. We have learned Bottle, is the web app framework. Again, we're going to be using that a lot. It's a micro framework for creating web apps. We've learned SQL with SQLite, and we've learned HTML, and we've learned CSS, and we just learned TCP/IP. So we're going to be using those skills today to create some of these apps. I'm going to go through now. I'm going to kind of show you the apps be created, and then if you want to stick around, we'll go through and explain how all of these works. So the first one is the Ping app. So do remember with this, always make sure you're running. So if Bottle is not running, web app don't work. So anyways, make sure it is running. So you click on the little run button up there, and you should get this thing listening on HTTP 127.0.0.1, which is the loopback address, basically the web address to loop back. And then we go to port 8080 because port 80 is blocked by default. That's an administrative port. We're only good for administrators. Anyways, so we're going to use port 8080. So now we're going to go over here and okay, so what we got here. So I got up. Come on, you stupid thing. Okay, so we go to 127.0.0.1, port 8080. And that's it, right? And basically what we get is we get a nice little instruction thing here. Again, give your users some instruction. Ping web app. Please add a host to the URL to begin pinging, such as HTTP 127.0.0.1 port 8080/CNN.com. So I go up here, I put in a /CNN.com, and then what is going to happen is we simply can use this as a ping test. So what's happening as this is going out, this is pinging CNN.com using the OS module. So it's using the ping command that's actually on the operating system. It's bringing back the results, and it's simply showing it on the screen. It refreshes every 10 seconds. So you'll notice every 10 seconds, we get this millisecond time that changes. Again, that's the kind of thing to be taking a look at with dynamic information. Just verifying that it is updating when it's supposed to. So anyways, this just gives us CNN.com. Yay! We get a nice little, nice little web app there. Okay, so then we're gonna go back. Let me actually, let me shrink that. Okay, then we're gonna go back, and then we see. So here, these are the connections that come in. Get CNN.com, whatever. Anyways, then we stop this. So you hit the little trash can thing, to kill it. If you have multiple things going on at the same time, again, yet another disaster. Then we come here to the multi. So basically what this is going to do is, so this is called a dynamic filter. So basically when you put the URL in, / and then whatever you want to ping or whatever else, you put any variable value there, that's a dynamic filter. What we're going to be doing here with multiple domain names or hosts is basically we are going to put multiple hosts in there separated by commas. We're then going to process that, separate those host values based off of those commas, and then ping the different ones. So basically let me run this here. So this is now running. I go here, again, same thing, 127.0.0.1, I've already got CNN there. So I can do fox.com, foxmsnbc.com, because I'm trying to be fair and balanced here, because that's the modern world. Again, if we try to triple click there, again, so we see CNN.com, fox.com, msnbc.com, and get rid of that, and we hit enter. And so now we can see that we're now pinging these three different sites, 3 different hosts. Again, it repeats about every 10 seconds. Got 37 milliseconds there, 31, 26, 38, 35, 27. And so basically this is what it's showing you is that it is auto-updating. Again, one of the things that could be useful here is if you did the same thing, but you were doing, let's say, google.com and your own 192.168.1.1, again, for real troubleshooting purposes, right? If you have equipment or if you had servers in your infrastructure, you're doing some troubleshooting work, this is the kind of script you could have up and running, and you could just verify that you can actually see the servers or the equipment that you're supposed to be seeing as you unplug crap. Because there's nothing quite like the lived experience of sitting there with really big switches and having to be a rat nest of cable. And that moment when you grab that RJ45 connector, you push down that little top bit, and then you make a little prayer to the spaghetti monster that this wire is the wire that you think it is. And if you have this going on, if it's not who you think it is, it will make your troubleshooting a lot easier. Let's see here. Okay, then we close that again. Then we come here. This is going to be color, and this is actually also going to be latency. Let me change this latency so we get some better colors here. So basically what this is going to do is we're going to get color coding. Again, one of the things you have to be thinking about whenever you create your application, whenever you're going to have a user using it, or if you're going to be using it, how can you add that user interface, that user experience to make it easier? Right, again, like what I showed you before, I mean, that's all just black on block text on a white screen. Yeah, you do have some numbers there, but if that's across the room, if you're not right beside it, it might be a little bit difficult to understand what's going on. So this actually adds color. So now we run this, same type of thing. We go here. Let's do that MSNBC, as we before, CNN.com, Fox.com, MSNBC.com, and we hit enter, and now we get color coding. Don't worry, it's CSS. You can put in whatever colors you want, right? So basically, if the site is accessible, so the site itself is accessible, it'll either be green or red as a background color. And then the other thing that we're doing here is that we're reading latency. So latency is how long it takes the packets to get from you to the server and back again. So if you're dealing with things like voice over IP, that might matter, real-time communication. And so basically we are reading off of the latency value here. And again, so this is over 50 milliseconds of latency, so that turns red. So it works. And again, that's one thing to be thinking about when you're doing troubleshooting. There's working and then working, right? You may be able to ping the site or ping the server, so it's pingable, but the latency might be so god-awful it's not usable, right? Touchable versus usable can be a major thing. So by having something like this, right, if this was your VoIP server, and this was your video server, and this was your FTP server, basically you can kind of try to show you what's going on there. So that's that particular lab right there. Oh, let's see here. We kill this, because we always kill them. And then we do SQL. So this is going to have SQLite as a backend. SQL, as the kids call it now. We used to call it SQL. Ergo, I will continue to call it SQL. Anyways, basically what we're going to use is we're going to use a database as a backend, basically as a way to save some configurations. All right, so we run it, always make sure for that to come up. And then we come here, none of that matters. So we do 127.0.0.1, 8080, and this is what we get, all right? So basically, we have our ping app, we have our home, and we have our test. This is probably too long for our particular class, but it shows you can dump a whole bunch of different hosts into here. And so basically what I can do is I can do cnn.com, next line of fox.com, next line 192.168.1.1, next line msnbc.com, next line, I don't know, tacobell.com. So anyways, the important thing here, nope, don't make it 2 words. The important thing here is basically this is just going to be a list of the different hosts that we want to be able to ping. Do make sure to go down and hit the submit button. So there's a save button. You'll be able to see it a little bit easier in yours. So you save it, submit, submit, so it's saved, and then we can click on the test. And now, again, just to make life easier, this is just black on white, CNN.com, Fox.com, 192.168.1.1, MSNBC, and Taco Bell. So basically the idea here is we can then go back to home. We go back to home, and we have our nice little list of hosts there. And then if we don't want to deal with something, let's say we want to get rid of MSNBC, and we want to get rid of Fox. Oops, damn it. We can then go back down to submit. We can do test. And now it's only pinging those 3. So again, it's a way that basically you can save those values into a database. And again, that's the kind of thing you have to be thinking about too. Again, we talk about data stores, again, whether it's a text file, whether it's a database, whether it's a SQLite database, whether it's MySQL, Postgres, Aurora, MongoDB, right? There's all kinds of different reasons you use different things. So again, like with this, we're using SQLite. SQLite has no security. You can literally copy and paste the entire database file, right? Again, if all I'm doing is saving, hosts, the configurations of hosts that I'm going to be pinging, I don't care if somebody copies and pastes that type of information. But that's the kind of thing that you need to consider. So past that, I'm gonna kill that. What do we got? We got Ping Sweep. So this isn't a web app. I was gonna turn this into a web app, then I got tired. Hey, I'm a human too. Anyways, this is an interesting thing to be thinking about. So ping sweeps are what all the brand new cybersecurity geeks are worried about. What happens if somebody can sweep the pings on my network? Basically, this is a core component of something called network mapping. So basically understanding what your network looks like. So ping uses the ICMP protocol that is part of the TCP/IP4 protocol suite. And basically what you do is you ping a device, basically say ping, and then it responds, and then basically what that tells you a couple of things. One, it tells you that that device is actually responding, so it's up, it's actually responding, and it also gives you that latency value I was talking about before. So, you know, is there a problem in the network? I've seen this before with switch loops. Again, it is adorable. It's adorable when people studying for their CCNA give me crap on YouTube. But one of the things I talked about in my last class was quality of switches, right? So if you buy a $10,000 switch, it is going to be better than a $30 switch. One of the things, the difference is between quality of switches and price points is something called a switch loop detection. And what a switch loop detection is again, remember switches, right? You have a switch, right? And then you have all your computers connected into the switch. Basically, all those computers have something called MAC addresses. There's a MAC address table that's in the switch. And basically, when one computer wants to talk to another computer, what happens is that communication goes in, looking for the computer with appropriate MAC address, and it goes out all of the ports. The computer with the MAC address responds, and that's where you get the resolution of an IP address to a MAC address. You know, 192.168.1.10 equals AE:0B: whatever the hell the MAC address is, right? That's ARP. That's Address Resolution Protocol. Well, riddle me this, riddle me that. What happens if instead of this cable going out to computers and servers and other switches, what happens if this cable goes to another port of the switch? Bad crap. If you're using a $30 switch and you do what is called a switch loop, basically what happens is when the communication goes in, it gets blasted out all the ports, and it comes back in, which means it gets blasted out all the ports, which comes back in, it gets blasted out of the ports, blasted out of the ports, blasted out of the ports, right? Anyways, so there's something called switch loop detection. If you're going to be putting a switch into a real business environment, pay the $100 for a switch that has it included. Anyways, one of the interesting things, though, is what happens if you have a really bad quality switch with a switch loop, right? So if you have a pretty decent switch and you have a switch loop, this is going to go around faster and faster and faster and faster until you just crash the damn network. All right, it really is. You can crash a network in about 15 seconds with this. Here's the thing. If you've got a switch from 20 years ago, a 10100 Linksys switch somewhere back in the server room, right, the computer that you might be trying to connect to, let's say the email server, might be connected to this. You're going in. One of the interesting things is this might be so slow, and I've actually seen this too, where the switch loop is slow enough to degrade performance of the entire damn network, but not fast enough to crash the network, right? This is what's called a soft fail. This sucks. Whenever you're doing technology, you want hard fails. I want my crap to fail spectacularly, so I know what the hell happened, right? If it fails spectacularly, then you know there's a problem. If you just kind of sit there looking at the network going, well, it seems like the network's not running as fast as possible as it should be, but it is running. That sucks. That just sucks. Anyways, so that's with a ping where you get the latency. Even for something like an email server, right? You may be, on your little switch here. So your computer is here. You do the ping. Your Active Directory server is here. You get good latency. Your FTP server is here, and you get good latency. But this goes through a switch. That then goes to the email server. The email server is on a switch with a loop. And then from your email server, you're getting like 400 milliseconds of latency. Right? That's where something like latency, you're like, oh, I'm not sure how good that latency should be, but it definitely should be a hell of a lot better than 400 milliseconds. But anyways, that's why things like ping is important and why something like a ping sweep can be useful. So basically all this is doing, This is running a ping command, so I hard-coded it in here. So this is for a Class C network, again, 255.255.255.0. So basically we're just dealing with IP addresses 1 through 254. That's all this is got to do. If you have an A or B subnet, have fun figuring out how to code that one. But anyways, all this is going to do is going to ping through 1 to 254 on the subnet that I'm on. So I have this hard-coded 192.168.1.1. That's my internal network. Your internal network might be the same. It might be a 10.0 network. It might be a 172 network. I don't know. So see about that. And then basically all that happens is when you run this particular script, this is what you get. Ping 192.168.1.1. And I get that return of milliseconds, 9 milliseconds. Dot 2, I get a return of that, 9 milliseconds. But look at this. Dot 3, I get 355 milliseconds. If this was a business environment, I'd be figuring out what the hell is going on with that, right? Dot 5, 411 milliseconds. Dot 7, 1200. Okay, I might not have the best network in the world here. 1200 milliseconds. Dot 9, 1400 milliseconds. Again, can you imagine if these were actually production servers, like a VoIP server? Can you imagine if you had an on-premises VoIP server? Your latency is 1400 milliseconds. That would be a complete misery. So anyway, so what this is doing is it's showing you the IP address that's being pinged, and then you can just kind of scroll across and take a look and see what the milliseconds look like. And again, you can see some of the systems are at 15, some are at 174, and some are at 1400. All right, so again, just one of those little useful tools. This will go through and this will ping every IP address from 1 to 254. What you'll notice down here is it starts to take time. So when it actually gets a response, it'll ping, it'll get the response, and it'll get it quick. 1400 milliseconds, really quick. If there is not a response, it actually does have to wait for the timeout. And so doing a ping sweep like this, with this particular type of code, will take a while. Probably 5 minutes, 10 minutes to fully run through. But anyways, it can be something that's useful. And again, something to be thinking about for you folks. Again, you modify this, you could dump this into a database, you could dump this into an HTML document, whatever else. Let's kill that. Then we go to the ARP. And then basically what this is going to be doing is we are going to be dumping our ARP table, and then it's going to be showing us our IP address, our MAC address, and we are going to use a REST API here to look up the vendor for the MAC address, so we can see the IP address, the MAC address, and the vendor to get a better idea of what's going on. So we hit run here. We'll take a second. So all this is doing is dumping the ARP table. So the ARP table is just created by TCP/IP when it's doing its networking stuff. We just has to grab that information. And so what we're getting here is some information that may or may not be useful. So 192.168.1.1, this is the MAC address. It's not in the database. Dot 2, that's a Netgear device. Dot 3, that's a GE device. Dot 4, that's an Apple device. Dot 6, that's an Apple device. Dot 7 is a Ring, Netgear, whatever the hell a microchip technology is, Murata manufacturing. I don't know what the hell some of this stuff is. You guys hacking my network? Anyways, so basically this is, again, a way to give you a better idea of how your network functions. And again, you could build this kind of functionality into something that's interesting for you. And then the final little project for today, before I explain all this is actually going to be using Bottle in order to basically get the IP, the MAC address, and the vendor information, but put that into a SQL database. So this is a very exceedingly simple version of machine learning. So basically we run this, wait for 127.0.0.1. So we go here, and we're going to run this the first time. So what this is going to be doing is it's going to be dumping from the ARP table. It's going to be resolving the MAC addresses to the vendors, and then we're going to see two things. We're going to see the results for this time, and we're also going to be seeing all the results. So basically what we're using here is we're using a database as a back end so that we can store information that's already been gathered. So one of the things that I found interesting with this MAC, this REST API for looking up MAC addresses, is it's not always the best. It has a nasty tendency of returning nothing, even when it knows something. It knows something, but it refuses to tell you every once in a while. So what you'll notice here is every time we run this, Up here, this is going to be different. Up here. So this is the latest response. And so 8 is for Netgear, and 22 is for GE Appliance, and Apple, and Ring, and Netgear, and all that kind of stuff. But every time, this is going to be changing. Well, the problem is, for me as an administrator, I won't have the best idea what's going on with my network. And so, what I have down here is I have a SQLite database. And every time I get a new record, basically, I'm going to be plugging more and more information here. So we run this once, we get a certain amount of information, that gets plugged into the database. We run this again, and then more information we put in the database. We run this again, and more information we put in the database, and all of a sudden what you'll see is this gets to be relatively full, while this, is kind of random. So again, we go here, and we refresh. So we'll notice, I should notice, this up here will change. Dun, 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 dun. There we go. So you notice this changes. So that GE appliance left, and some of these other things shifted around. And if we come down here, what we'll notice is we've started to flesh out the database a little bit more. And so down here, we have a more complete set of records. This only works 2 or 3 times, but it kind of gives you that idea of how to start adding information. And again, it's an exceedingly simple concept with like the idea of machine learning. Okay, yeah, now look at that, right? Now it's actually far more filled in than I realized it was going to be, right? So this is what we got out of the last resolution, and this is all that we got. So this is the value of having that kind of database back end. So every time new information comes in, we can just plug that in, and then essentially it's a caching mechanism, so a way of saving that information for the future so that I could actually use this in an app that I'm creating. And so those are the 6 or 7 different little projects that we're going to be working with today. And in the future, we are going to have more and more of these types of classes, types of sessions, so that folks can start understanding how things work. Jock is raising his hand. Jock, what's up?
Hi, just made it home, so I'm going to switch to my computer. But I had a question about kind of like my understanding, and I think I know the answer to this, which is going to be no, but just wanted to ask it anyway. So, dealing with like servers and switches, and the way you explained it before, theoretically, could I take an old Xbox and convert that to a server or switch because it has its own MAC address, in a sense, or no?
That is an interesting question for after class. I need the questions to be on this stuff right now. Again, at the end of class, more than happy to answer that type of question, though.
Thank you.
Yep, that gets into its own world. Again, discussion points. It was funny. I was doing the physical in-person classes, and yeah, one of the nastiest arguments I had seen in quite a while is when I had a student asking questions slightly off of topic, and another student lost their damn mind. So, more than happy to answer that question after the rest of this is over. FB man, waiting room. FB man, did you have a question? Okay, does anybody have a question? We're about to go into the code itself, but is there anything conceptually you don't understand what's going on? So FB man says, I am having issues running the ping scripts on Windows. The -c argument appears to differ from Linux Mac. Could I run this in a Linux VM instead to prevent such issues? Yes. If you run a Linux machine, VM, it's called a virtual machine. Basically, it's called an instance. That's its own operating system. As far as computers are concerned, it actually has its own MAC address. That gets into its own world. But yeah, if you run an instance of a virtual machine that has Ubuntu or whatever else on it, this should all run completely fine for you. Again, as we go forward, as I've completed more classes, I am going to try to make these classes more Windows friendly. I do want the Windows users out there to understand I'm not trying to be mean to Windows people. It's just Windows computers are a pain in the ass to deal with. And so I've only got so many hours in the day, and so we'll support you, Windows people, just not quite yet. So yeah, no. If you want to run any of these, if you know how to create a virtual machine on your system, throw Ubuntu onto it. All this stuff should work fine. Also, there's that whole Linux subsystem for Windows. Not saying it's gonna work, but it should work. So Microsoft a little while ago put out the whole Linux subsystem. So Linux commands should run on Windows. Again, another thing that I have not played with. So maybe that'll work. Let's see here. WSL, yeah, it's called WSL. And again, one of the things I have to deal with. Okay, so let's go back to the ping. Ping, 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 ping. All right, so basically what we're talking about here is when we run this, all we're going to be doing is cnn.com. So basically, we put in 1.7.0.0.1.8080/cnn.com or 192.168.1.1 or fox.com or MSNBC. You do what you want to do. It will then ping it. It refreshes it every 10 seconds. So you'll see your latency changes. And so that's going to be an important thing with all these classes is I do want you to have that dynamic component so that you see that it's doing something. Rio, Row, why are people... Anyways, okay, so let's go and take a look at this. Again, if you don't have it running, then it's not on. Just to be clear, I'm gonna turn that off. Okay, so this is very simple. So we're using the bottle module. So again, pip python 3 space -m space pip install bottle. That's all you have to do in order to get bottle installed onto your system. So from bottle, we're going to import run and we're going to import route. That is all that we need to make this run. And then we import OS. So the OS module is what allows us to communicate directly with the operating system. We have our route, and our route here is for the initial index. Then we have a route with that dynamic filter here. And at the end, we have this run command. Right, so this run command down here is important. So we say run. So this is what actually runs it. If you forget to put this in here and you hit go on the script, it like runs, but it doesn't do anything. Anyway, so what run is what makes it actually work. I do want to talk about this host for a second. So you're going to see I have host, single quotation marks, 127.0.0.1. So this is what is called your loopback address. Now you can put many different host names in here. So if this was actually being run as like a web service, you might actually have a DNS name in here, right? crappyapp.com. You can put that in there, and so basically it knows that's the app it's supposed to be working for. Now, when you're doing these local little simple projects, with this, there's three numbers or configurations you can put in here. So 1.7.0.0.1 is the simplest for you folks, and the reason that I used it in these classes is so that you remember what the hell it is, right? So listening on this, and if you hover over it, you can actually click on it and go there. Right, so that's going to be the easiest, especially for noobs. So that'll work how it's supposed to. This also could be localhost. So localhost is a DNS name for 1.7.0.0.1. So it's localhost. You go to localhost within the host file. You should go to 1.7.0.0.1. And you're there. The other one, and what you'll normally see in bottle configurations, is 0.0.0.0. And what that means is that it will accept a connection on any TCP/IP address that is connected to this particular computer. So especially imagine if you have a server with network cards, you can have one physical network card that might actually have 4 ports in it. There might be reasons to put multiple of those cards in there. So theoretically, you could have like 12 network connections on a single server that's actually functioning. There's reasons that you would do that, load balancing, multi-layer networks, probably not stuff that you're going to be messing around with, but basically by doing 0.0.0.0, what it says is if any communication comes in looking for this, accept it from any one of those networks. So anyways, so you see 0.0.0, basically just remember 1.7.0.0.1. And then we do port 80, again, port 8080. Do you remember port 80 is the default HTTP port? So when you go to cnn.com, that's using port 80, but because it's the default, you don't have to put it in there. With most of these computers nowadays, it's under administrative privileges, so you can't just easily use port 80. I can't just easily use port 80 there. So by using port 8080, 8080 is the alternative HTTP port that doesn't have security privileges around it, so we use port 8080. So that's what's going on there. Can we also do localhost? Yes, you can. Okay, so the route. So we take a look at this. So this is called a decorator, the at route. So a decorator is a function that kind of adds functionality to the function that's directly below it. And so basically the at route decorator is what route is this? And so we're just simply using a /, and so that means the root directory. When you go to 1.7.0.0.1:8080, this is what you'll get, right? We're going to define the index page. Let's define index page equals, and then we're using an F string here just to make this easier. H1 ping web app. Please add a host to the URL to begin pinging, such as blase blase. Right. So so if you just go to the root, that's what you get, and then we return the page. We return all of this information. I can collapse that. Then we're going to come down here to this. So we do at route. So we now have /, and a little arrow thing, and then host. What this is saying is that the value that comes in here, this is going to be a variable value. And by default, it's string. So with these filters, you can have ints, you can have other things. By default, if you don't change anything, it's going to be strings. So basically, the value that's going to be coming in, that value is going to be the host. It's going to be host. So to find, you're going to just do index again, host. So host from here is coming in as host here. So basically, this is the value that's coming in this function. And then we're going to do is we're going to do try except finallys here. So try. Response equals os.popen. So what popen does is it sends the command to the operating system, and then it also receives the response back. So that's important. We're doing this nasty F string here. Again, whether or not this is the best way to do stuff, I don't know. I'm just kind of showing you how things can work. There's something called subprocess module, which is probably a better way of doing this, but oh well. So F string. So you're going to do ping space -c space 1. So if you're using Linux or Mac and you run the ping command, it will run forever unless you manually break it or you put an account to tell it to stop after a certain number. So we're going to say ping once, space, and then the value for host that's come in. So cnn.com, 192, whatever else. Then this is going to come back as an object value. So we do .read method, and what this is going to do is this is going to turn this into a text value so we can return this to response. So we're going to say try to do this. Again, if it fails for any reason, if this fails out, response equals problem connecting. So maybe the network card has failed, maybe your device drivers are dorked up. I mean, you're using Windows. Any number of problems can happen, right? And then the next thing down here is you might just get a blank response back. Like and that's what you have to worry about with the OS commands. The OS commands have a nasty habit of working. Technically, they just don't give you anything that's worth anything. It's like the command worked, but you got nothing back. So basically what this is saying is finally. So finally is at the end of a try except statement. So regardless of what happens beforehand, finally. So all this is saying is finally. If response equals nothing, response equals host could not resolve. So basically here, if for some reason this works, but you don't actually get an answer, you just say host cannot resolve. Header equals, so this is the meta tag for HTML that auto refreshes the page. So I'm sorry, it auto refreshes every 5 seconds. So meta equiv refresh every 5 seconds, and then we're going to create our page here. All right, the page equals header, so the header is going to go in, h1 for the host value that came in, and then the pre tags means basically we keep the same text formatting in the HTML version, and we're going to do the response for whatever comes back in, and then we're simply going to return page. And that's all it is. Again, like I say, if we go and we take a look and we run this, and we go back again, like cnn.com, that's what we get. I don't know, cnn blah blah blah. There you go. Cnn blah blah blah, host could not resolve. And so that gives you a little bit of differentiation there. And that's what we got for the first project. Any questions for that? I think it's pretty simple. Just answer my question. Okay, let's see. Oops, are there more down there? Yep, okay. So then we go to ping multi. Basically the same thing, only we're going to be using the split method and doing a loop. So from bottle, import run, route, import OS, route, exact same thing before. So if you go to roots, you're just going to get this, basically, again, an explanation of how you're supposed to actually use the code. And I will tell you, again, a lot of times we talk about this kind of thing for users. The stupid users, we need to give them this information. Let me tell you, if you put down the tool that you created 6 months ago and then go back to use it, yeah, you might be a stupid user too. Putting like little simple hints in your apps can be very useful. So anyways, now we're going to go here. Exact same thing before, right? Route host. All right, so let me run this, just so you understand. We go here and go CNN.com, Fox.com, MSNBC.com. All right, so basically it's the same thing. Now this is all together, so there's no spaces or anything else. Just CNN, comma Fox, comma MSNBC, and it's going to print all of those. So we go and take a look here. Basically, all we're doing here really is we are going to be using the split method. So that host value is coming in. The host value is going to be CNN.com, CNN.com, comma Fox.com, comma MSNBC. Right. So that comes in as a string. I don't want that whole string. I want the individual values in the string. So we use the split method. So host list equals host dot split wherever the hell there's a comma. So if there's a comma, so now CNN.com is going to be at index 0, Fox is going to be at index 1, MSM is going to be at index 2, so forth and so on. Then we're going to create a value for body. So basically the body of the email, or not the email, the web page that we're going to be creating. So we're going to basically be creating that page. And let's see here. So body equals nothing so that we can build onto it. So for value in host list, so CNN, Fox, MSNBC, value equals value dot strip. So dot strip is a method that will strip off the white space to either side. So white space can screw you up, especially when you're running commands. You just want to make sure it's clean. You don't want space, CNN.com space. You want CNN.com. Try, same thing. We're going to ping and read the value, except problem connecting. If it's blank, could not resolve. Then we're going to go down here. And so this is within the loop. So the body is within the loop. So the body is blank here. So we're going to do an F string, whatever was in the body before, H1 value, so this is going to be the host name, and then pre-response. So the first time it runs through, body is blank, we're going to add CNN with a response. Next time it runs through, CNN with a response, add Fox with a response. Next time it goes through, CNN response, Fox response, add MSNBC response, and that's how you're able to dynamically build this body component. We have the header like we did before, and so now we have the page. So header, that goes up at the top, and then body, that's all the results, and then we return that, and that's what gets us our nice little page that again auto refreshes about every 5 seconds. Basically same thing we did before, only with that split. Any questions on that? My golly, we've already gone through an hour of class. It's kind of funny, like whenever I do these classes, I'm like, oh, this is only going to take 15 minutes. Oh, we're just going to rip through this in 15 minutes, and what are we going to do for the rest of the class? And I'm sitting here talking for 4 hours. Anyways, okay, so the next one is the color. All right, so we run this one. We do this. And again, same type of thing, CNN, Fox, MSNBC. But now, instead of getting the full response, we're only pulling out the line that says time on it. And then what we're doing is based off of that time, we're changing what the background colors are. So if the site is accessible, the background color will be green. If not, it'll be red. So that's for the site itself. And then we're using this latency here. And basically you have sage, or you have light green for good. You have yellow, you have orange, and you have red. And that again tries to show you the actual status of how that particular page is doing, that host is doing. It's the same kind of thing. From bottle, import run route, import OS, same as before. Now we're going to be creating a dictionary for the latency values. So whenever we talk about latency, again, it's the time going from your computer to the server back again. Good latency latencycycycycy again, especially for voice over IP, it matters. Voice over IP, video game, that kind of stuff. Latency really matters. Apparently, supposedly, you can have latency up to like 99 milliseconds or 100 milliseconds theoretically on VoIP, and you won't run into problems. I wouldn't want my latency above 50 or 60 milliseconds if I'm using VoIP. But anyways, there's different things, right? So VoIP has a good latency, FTP has a good latency, different things. So anyways, you can just plug this in here. Again, anything on the local network, you should have really freaking low latency, right? Again, you're pinging on your LAN. So it should be like sub 10 milliseconds latency. But so here we have good, I just put it at 20. Usable is at 30, and bad is at 50. Shaman, what's up?
Hello. If I put three URLs, like say for example CNN, MSBC, and let's say BBC, does it all send the request at the same time, or it actually first send the request to CNN, then returns back, then send the request to BBC? You get my point.
Yeah. So it's a loop. So you have for value in host list. So for CNN.com, it runs it. And then for Fox.com, it runs it. And so so that's why, like I say, you're building up. Yep.
Yeah. Thank you.
Yep. Oh, Jock, what's up?
Question. Can you hear me?
Yep.
So because we've done these like something like this project before, the latency would be lower because it's in our cache, wouldn't it?
No. With the ping, ping doesn't cache. No, this is real time.
Oh, okay. All right.
Yep.
Gotcha.
Cool. All right. So let's go and take a look at this. Okay, so we got this, and so this is what we can measure against with some if-else statements. Again, route, index, same crap we did before. Okay, route host, again, comes in. So we have, what did I do here? I put the command here. So command equals ping -c1 space arg equals space grep time. So basically what grep is allows, is a Linux tool that when you get a response back from a Linux command line tool, you can simply pick out things from a specific line. So if we go to terminal here, right? Oops. Hello. So if I do ping c1 cnn.com, all right, so I'm going to get all of this back. And now one of the things you have to be thinking about is when you're parsing. So what parsing is when your script has to read this mess and then do something based off of it. So one of the things that you want to do is you want to try to clean this up as much as possible so that your script is dealing with as little as possible. Again, that's where we talk about like really building, when you're building your apps, there's multiple layers to it. So one of the things you can use is grep. And so it will only return things, basically lines that have certain words in it, right? So if I take a look here, let's say with equals, right? So let's say time equals. So what if I just wanted any line that has equal in it, right? So I could do ping -c1 cnn.com pipe grep, and then I can simply do equal. So just give me the line with equal in it. And when I do, now we'll see I get 64 bytes from 151.101.35, and I get that time, I get that, but then I also get this additional information down here. So this is better. It's easier to parse this than all this, but that's still not quite perfect. So what I can do is I basically just do the same command, but if I do time equals, right, that was specific to a specific line, and then what we see is I only get that one line back. So instead of having to parse 4 or 5 or 20 lines of text coming back, I'm able to simply parse this particular one line of text that's going to be coming back. Philippe, what's going on?
Can you hear me?
Yep.
Okay, just a bit curious about when you did a few minutes ago about the test of the pings in the local area, and you were surprised that some of them were really high. And I was just curious why it might be. Was it? Do you think it could be something related to the cables, because that's really weird?
Yeah, I have a lot of crap on my network, honestly. I mean, again, it's my home network, and B, I'm a computer geek, so I shove stupid crap on my network. So I have to find out what those particular devices are. They're just probably just pieces of crap. I mean, like I said, I've got weird little IoT devices on the network, so it might be like the I have Ring cameras. Their latency might be bad. I don't know. It's one of those things to take a look at. Yeah. But yeah, it could be, like I say, most of the time you're going to be running into things like switch loops or again, bad cables. Maybe they're old cables that they've been bent up a lot. Or it can be network cards. Again, if network cards start failing, you can run into some weird problems. So it could be any of those issues. Yeah. Yeah, cool. Just so you know, if you unmute yourself, keep yourself unmuted until you're completely satisfied, because you can't unmute yourself. Only I can ask you to unmute yourself. So if you unmute yourself, or if I ask you to unmute yourself and you unmute yourself and then you mute yourself to let me answer, and then I have to ask you to unmute again to make sure you're okay. So I hope I answered your question, Philippe. But yeah, yeah. Where are we at? grep. We are at grep. So we're going to do the arg grep. So host list, host.split, as we did before, body, as we did before. So for host in host list, so basically for every host in that list, color is going to equal blank. So we want to make sure the color value is blank to begin with. Latency color, we want to make sure that's also blank. And then we're going to do host equals host.strip. So we basically strip any of the white space. Basically the same type of thing before, only we're adding that arg in. Again, to be clear, for any Uber geeks out there, probably should use subprocess. I get it, we probably should use subprocess. We're not using it. Anyways, os.popen, doing an f string, command value, space host value, space argument value, and then we're gonna read. If that fails for whatever, like fails for any reason, we're gonna get a problem connecting. Else, what we're going to look at is if time is in response, color, so basically the host color is going to equal green, else color is going to equal red. So again, when we start taking a look at that whole ping thing, we're looking for anything we can work with, right? So if I do ping cnn.com grep time equals, so I get time. Well, oops, I forgot to do C. No, ping -C1. Why is it doing that? Oh, what the hell? Anyways, supposed to do C1. That's why you have to be careful. If you mess up your command, this is what will crash your server. Anyways, so I ping cnn.com, I get the response back. This is the response that I get back. And so if I get this response, I know that this worked. I know the site is up in general, regardless of what the latency is. Again, if I do ping C1, and I do cnn.com grep time equals, and basically it's going to come back as a blank because that's not resolving for whatever reason, and so it's red, right? So I get the time equal. I know the site at least is up. If I don't get the time equal, most likely the site is down. So that's color equals green or color equals red. Okay, so response list equals response.split. So what that means, right? So what the split does is, so this is the string that's going to come back. But again, parsing, you actually have to do something. So what we're going to do is we're going to split the string into a list based off of the spaces. So wherever there's a space, that's essentially going to be like the equivalent of the comma. So 64 is going to be a 0, bytes will be a 1, from to 151, whatever, at 3, ICMP at 4, TTL 5, time at 6, MS at 7. Will be at those different index points once we do that split. Then once we split it, right, so we split it, so if time, so for value, So now we're going to go through this list that we've created. So it'll do 64, and then it'll do the IP address, and it'll do all those things. So it's going to loop through. If time is in one of those values, right? Time underscore list equals value dot split. So we're splitting again at the equals. So what's going to happen is it's going to go 64 is not time, bytes is not time, from is not time, 151 is not time, ICMP is not time, TTL is not time, time is time, right? This index has time in it, so we're going to grab it. But then, what do we care about? I don't want all of this, I just want that. So I can take a look at this and I can say, hey, if we split off of the equal, then time will now be at index 0, and 31, whatever, the milliseconds, will be at index 1. And that's something that we can actually do something with. All right? So, so we're going to split. Latency equals, so when you do this, it's going to come back as a string. Again, do be careful, we can't do conditionals based off of string, so we have to use float. So this float function, so time list at 1. So time is here, the actual milliseconds is here, time is at index 0, the actual milliseconds is at index 1. So we're going to do time list at index 1, we're going to make sure they're a float, and we're going to call that latency. So if latency is less than latency quality good, so we're going to take a look up here, right? Latent quality good is 20 milliseconds. So if it's less than good, so it means it's faster than that, then we're going to say latency color equals light green. If latency is greater than good and less than or equal to usable, we're going to make it yellow. If latency is greater than usable and is less than or equal to bad, we're going to make it orange. If latency is greater than bad, we're going to make it red. And God help us if we get some weird ass number in there we don't know what to do with, we're going to make it purple. Again, I like putting these little final else's. Like you look at this and you would think the red would be the final one. I like putting an else in there. Again, just in case something happens with weird, I get purple. So that's going to create the latency color for us. Again, we're taking a look at this. Do remember this is a word wrap. So see how everything's on one line here? As I make this larger, see how it kind of comes down? So, just word wrap. Some people get confused about word wrap. Finally, if response equals nothing, host could not resolve. Body equals, again, so the body, whatever the body was before, so blank. Now we're going to say h1 style equals double quotation. So these are single quotations, right? Remember, don't fuck up the quotation marks. Single quotations on the outside, double quotations on the inside. Style equals background hyphen color, colon, and so the color. So green or red, based off of there is time in the results. Semicolon, double quotation, and then we're going to plop in whatever the host value is and close out the H1. Then we're going to do the pre. So this is that pre-formatting for anything that comes in as a text value. So pre-formatting style for that equals background color. We're going to make that latency color, and then we're going to plug in the response. And so that's where we see all the little response colors down there. And basically this is where it goes and it just builds. First it does CNN, then it does Fox, then it does MSNBC, then it does Taco Bell, whatever else, and it builds up that body doing that. We have the auto refresh as we had before. We're basically creating a page of the header and the body, and then we're returning the page. And then when you run that, that is what you get. So everybody understanding splits. You understand with split as a method, basically what you're able to do is you're able to go into a string. You can find it might be a comma, it might be a space, it might be some other type of delimiter, and based off of that delimiter, you can then break that string into a list, and then you can deal with the individual indexes within that list. Does everybody kind of understand what's going on there? All right. I will accept your quietness, as you all know exactly what I'm talking about. Okay, then we get to SQL. Then we get to structured query language. So structured query language, again, is a relational database. basically all we're doing for this particular lesson here is we're just using it as a way to store configuration information. Basically, we're gonna plug in the different sites that we want to ping. We're gonna store that into the database, and then once it's there, I can turn off the computer, turn the computer on, a year from now, and all of that information still resides. Like once you put in the database, then it's not just going to disappear. So basically, with this, again, bottle import, we're going to do run, route, request, post, and redirect. Got a couple more things going on here. We're going to import the OS module, and we're going to import SQLite 3. Do remember to put that 3 at the end, or you will run into problems. Again, just to make sure you know what's going on here. This is this particular script, right? So we have the values in our little text area box here. And then based off of those values, I can hit test and it'll test for the values that are in there. I can then go back to home and I can change those at will. That's what we're looking at. Okay. So we're going to put in a database value here. So remember, with SQLite, one of the great things about SQLite is it'll either connect to the database you tell it to, or it will create the database that you put in here without having to do any other configurations, right? So basically, by simply saying database equals ping.db, what I'm saying is either connect to ping.db or create ping.db. Do you remember that with this too is that by default, this will go to your root directory. So your root directory. So the Eli folder, right, has the ping.db. It has this database. And as you can see, it was actually created at 228 today. So it'll be in your root folder. Don't simply expect this to be in the folder wherever your script is. Okay, let's see here. We're going to create a header here. This is just creating the these little links up here. So a home link and a test link. One of the things to think about as you start building these apps is how do you actually navigate around in the app itself. That's all I did for the header there. Then we come down here. We're going to define. Let me close these up so we can kind of go through this in a logical format. Okay, so what we have here is we have a db create function. This is actually creating the table. Again, one of the nice things with SQLite is you have this command to create a table if it doesn't exist. So we're going to connect SQLite, we're going to connect to that database value. We're going to create this thing called a cursor that allows you to interact with the database. And then we're going to have this SQL command. So create table if not exists. So if this table doesn't exist, it'll create this table. If it does exist, it won't create the table. It'll create the table host with a single column of host list. We're actually only going to be using a single record and a single column. It gives us a data store though. All right, so it'll create host with a column of host list. And again, the nice thing with SQLite is you do not have to assign data types by default. You don't have to do a lot of the other stuff if you just want to dump text information in there. You're going to do connection commit. So you execute this, but it doesn't really execute until you commit it. And then we're going to close the database. Now, the important thing to understand though is I put this up here as a function. So this is a function. So the function is just sitting there until you call it. So if we scroll all the way down, we see this is where I call the function. So basically, when the script runs the first time, it'll go all the way through, it'll fire off this function, which will then create the table, or not create the table, and then it'll actually run at the port. So you create this function, and then you run it here. And the reason to create a function, just from a visual standpoint, is you can do things like collapse the function and that kind of stuff. Anyways, then we're going to come down here to our route for the index. Okay. Yeah. Sorry, gets a little tiring after a minute. It's like, what the hell am I talking about? Okay, so our route is to root. We have our index function, no value comes in. The first thing that we're going to look for is what hosts are already in the database. Because basically we need to populate that text area box with those values so that we know they have. So host is going to equal the db underscore find host function. So we go up here to this function. Okay, we're going to connect to the database. We're going to create the cursor. We're going to try query equals cursor.execute, select all from host where row ID equals 1. So basically what this is going to do is it's going to select the values for the first row ID in the host value. So it's going to go through and it's just going to get that information. You're going to fetch 1 just because you're only should be getting 1, and query equals query at index 0. So when you get the results back, the value that we want is going to be at index 0. If for some reason this doesn't work, query is going to equal nothing, and then we're going to finally close the connection, and then we're going to return this value back. And basically what we're going to be getting here is we're going to be getting the comma-separated list of values. A next line separated list of values. Getting a little warm in here. Getting a little hot under the collar. It is. It's like, yeah, coding, technology is all fun until you have to sit here and actually explain this stuff. Okay, then we're going to go here. So basically we're going to go to our database. We're going to find that one single record. We're going to pull the values out. The values that are going to be in that record are going to be separated by a /n. So /n is the next line, right? So when you take a look at this, think about this, cnn.com/n goes to next line. 192.168.1.1/n goes to next line. TacoBell.com/n goes to next line. So instead of having commas or spaces, we have /n for the next line in ASCII. So we're going to split those so that we have a list. Host output equals nothing. So for item in host. So this is a list. For each item in the list, we're going to strip. So strip to either side. If there's spaces, there's more likely going to be a space here. Host output equals, the host output item. So what am I doing here? /n. Oh yeah. Man. So basically we go to the database. Probably didn't have to do that there. Beta classes, I will say. Probably don't have to do this whole thing there. Anyways, yeah, we're splitting on the n and then we're adding the n back. That was a dumb idea. Fuck, that was a dumb idea. Anyways, so we get all these values back. They're separated by the /n, by the next line. We then create the host output variable, and then basically, we're recreating what we just killed. So host output with the item with next line. So cnn.com, next line. cnn.com, fox.com, next line, so on and so forth. Anyways, page is going to be header. So basically what was up here in the header for the URLs, or for the hyperlinks. And then we're going to have the form action. So form action equals db insert. So basically take the information and insert. Method equals post. Hosts, we're going to have a text area. The name for the text area is going to be hosts. Rows are going to be 50 rows. Column is going to be 50. So that's what gives us our little box. And then we're going to plug in the output that came in from the database. So all the values that were already in the database, we write those into the default area for the text area so that they're already here. So basically we can modify this. And then we close the form and then we return the page. So we have a submit button here and we return the page. So basically that's what creates this. Then when you click on the submit button, right, that is going to send us to the db underscore insert. So go up here, db underscore insert. So you'll notice we have a decorator of post. So before we had the decorator of route, this is the decorator of post. So when you're going to be sending post information, you need to have that post decorator. and /db insert, right? Hosts equal request.forms.get hosts, right? So basically this is just simply getting the values coming in from the name of hosts from that form. Connect to the SQLite database, create the cursor. So try cursor.execute update host set host list equals question mark where row ID equals 1. So basically what this is going to do is, again, we only want to deal with one little record, one column, one record in this database. So basically where row ID equals 1 for host, we want to update that. So change it, question mark, and so the host value comes in here. So cnn.com/n, fox.com/n, MSNBC, whatever, that is going to get updated here. If cursor.rowCount equals 0, so we're going to try to update. If that update fails for some reason, because the record doesn't exist, because that's one of the things, once you've run this once, the record exists, so it's fine. The first time you run this, the record doesn't exist yet. So you can't update a record that doesn't exist. So if you try to do this execute, and the row count for the execute is 0, because that record doesn't exist, then you're going to execute insert into host list, value question mark, hosts. So basically, if the record exists, update it. If the record doesn't exist, then we're going to be creating it. Except, print out database problem, and then finally, you're going to commit, and you're going to close, and at the end, you're going to redirect back to that home page. So back to this route here. Then we go and we take a look at it. We have the test, or we have the ping. So we click on that. That'll go to ping. And what we do here is, again, we have route, decorator, the ping, define ping. We have the refresh every 5 seconds with the header. So it's going to refresh, and then we're going to get the hyperlinks and things. Host equals db find host. So we're going to go to that table, to that record. We're going to pull. Here, we're actually going to split them. There is a point to split them on the next line. So cnn.com will be at index 0, Fox at 1, so on and so forth. Then for item in host, so for each item, we're basically going to strip the white space. Command is going to equal ping -c 1, cnn.com, Fox, whatever. Try response os.popen, the command.read. So we're going to run this command, and we're going to read it, except there's a problem. And then page is going to equal page, add item, add response, create. And that is what's going to get us that. For the love of God, did that make half an ounce of sense? Hope that made more sense to you than it did trying to explain it. So yeah, basically with this, again, we're starting to use more functions. We're starting to interact with the database, and you start having to think about things like creating the table, how you're going to be interacting with the table, how you're going to be updating the records, whether you're going to be inserting the records, that type of thing. We got that. This is going to take me a week to recreate. That makes me feel better. Can you explain the connection values question mark? Yes. So here, right? So whenever we're going to be running SQL statements in Python, you'll notice I use these question marks. So you can run the actual SQL statement. So I could create an F string here and do the squiggle bracket hosts, right? And actually dump the actual variable values directly in. The reason that you don't is something called a SQL injection attack. So basically, if I'm running the SQL statements directly against the database as they are, a hacker could use a semicolon to exit out of the statement that's currently occurring, then literally type in another statement, run another statement, semicolon at the end of that, and then basically what would happen is the first statement would fail, their statement would work, and the rest the dregs of the first statement would fail again, right? And so that's something called a SQL injection attack, and something that you have to worry about. So basically, what these question marks do, and so again, whatever language you're using, they're going to be interacting with SQL. Almost all of them, they use this. And so basically what you're doing here is you're saying question mark, and then at the end, you're giving the variable values. And again, this is one of those. How it fully works, I'll let you go talk to the database people. So basically what it does is when it puts that variable value in there, the variable value is going as kind of like a contained unit so that somebody is not able to exit out of it, I guess theoretically, and launch a SQL injection attack. So that's why you're using these question marks here. Again, you could do full-fledged SQL statements, but especially if you're taking information from user input forms, there is a possibility that they could do a SQL injection attack. Doing it this way, again, is supposed to prevent that. It's supposed to prevent that. It's like with MySQL, in the database itself, there's something called prepared statements. And again, it's kind of the same way, where basically how the functionality of the prepared statement is designed in such a way that when the variable value gets dumped in, it can only be a variable value. You can't muck with the rest of it. If that makes sense. So you're just storing the entire raw string from text area into the database. So the table host list contains one row, which is a raw string like cnn.com, blah, blah, blah. And that's why we need to split it when retrieving from the DB. Yes. Yay, you're following along. Yes, you're following along. Yeah, it's crappy. Oh, it's crappy, but it works. Yes. So basically, you have so what you have, like you have your database, right? You have your database. In the database, you have a table. That table has one column, like host list, I think it's called. And in that, you have row ID 1, right? So I guess it's row, well, I can't even write this correctly. Okay. So you have a host list table. You have row ID column, and I guess you have a host column. And so basically, you have row ID 1, and then all you're messing with is one single cell and one table on the database. But it works for this. Again, there's other ways to do it. Again, one of the problems you get into, again, with trying to teach, trying to explain, is, again, think about it. For anybody that's actually a coder out there, do you want to do this? Do you want to sit here and explain everything? Like, it gets to be difficult to start explaining more complicated stuff. So I figured this kind of explains it. There's other ways to do it. Anyways, any other question? Okay. So let's get to a ping sweep. Ping sweep's easy. Yay, easy one! Oh God, I need a cup of coffee. Okay. So ping sweep is simple. Again, basically all this is going to be doing is going to be literally doing a ping sweep. So it's going to start at 192.168.1.1 because that's the subnet I'm on. I'm on 192.168.1.x subnet. What you're on, I don't know. It might be a 2.x subnet. It might be a 10.0 subnet. I don't know. Figure it out. So anyways, it's going to start at 1, and it's going to go all the way up to 254. Basically, if we run this, then we're going to see, so we get the results for 1.1, and basically it's just giving us our latency. Again, 1.2 gives us our latency, 1.3 gives us 435 milliseconds, 0.5 gives us 200 milliseconds, whatever it is. 0.9 gives me 946 milliseconds. And so basically this is a way to go, and you can do a ping sweep. Again, with the other stuff that you've learned with Python at this point in time, you could output this information. You could create a table to an HTML file, so you could get the ping sweep results in that, and you could share it with somebody. Again, you've been using Bottle. You could do this within Bottle. The concept of this ping sweep is this was going to be built into a Bottle app. The problem is it takes so damn long. Again, with the timeouts, if you actually get a result back, it's quick. but with the timeout, it's like 5 seconds or something for timeout. So to run through 254 254 IP addresses, again, like I say, it takes 5+ minutes. So anyways, again, that's kind of design consideration that you have to think about. Okay, really simple. So import the OS module as we do. We're going to create the subnet. So my subnet is 192.168.1.x, right? And again, that's a class C subnet, 255.255.255.0. The command is going to be ping space -c space 1 space as before. Arg is going to equal pipe space grep time. So I just want to print that out so we get something, that's pretty easy to look at. We're going to start at IP equals 1. So 192.168.1.1 is where it'll start. While IP is less than or equal to 254 as a conditional, response equals os.popen command. So command and then space, and then subnet and IP together. So 192.168.1.1, 192.168.1.2, 192.168.1.10, right? Space the arguments, and then we're going to read. We're simply going to print out the subnet with the IP, hyphen, and what the response is. We're going to iterate the IP by 1, so IP plus equals 1. That's how you iterate in Python. Again, different languages, plus, minus, that type of thing. Python is plus equals, and that's how you iterate up by 1. And that's how you go through and you do that. Yay. Can we use ip-api.com to find our subnet? Basically what you use is Wi-Fi settings, details, TCP/IP. So my IP address is 192.168.1.4. Subnet mask is 255.255.0. My router or default gateway is 192.168.1.1. And that's where the information would be. So again, Windows has their own version of this. If you're using Mac, just use IP space address. That should give you this kind of information. This is where your IP address and subnet mask will be located. Some kind of gooey-ish like that. Again, the kind of thing that ChatGPT is very good for. It's not artificial intelligence, but it does give some good answers. So I don't know, whatever OS you're using, use that. So yeah, I don't know what IP-API. Yeah, it's not your external IP address. So remember, when you're dealing with TCP/IP, right? Basically, you have the internet cloud, more or less. You have your router coming in. Under that is your switch, and that's all your devices, right? So there's the external IP address, 151.66.44.5, and that's going to be, and then it's going to have a subnet mask, most likely an A, 255.0.0.0, something like that, right? That is going to be your external, and so that's what you would go to for any kind of like API calls or whatever to give you some information. That is not what we're dealing with now. Internal to your network, right? Because your router has NAT, has network address translation. So internal to your network, you have 192.168.1.x, right? That's the network I'm using. 10.0.1.x, or either 10.0.x.x, something like that, or 172. Whatever the hell the 172 network is. Because again, I have not used it in 15 years. So these are the internal to your network. And that's basically whatever the hell either the admin configured or the default configuration that came when you pulled your router out of the box. Yep. Cool. Okay. There we go. We still got some people here. Yay! We still have people. Really kind of sort of figured I'd lose everybody at this point. Anyways. Okay. Now we go to our ARP tool. So basically with this, what we're going to do is we're going to dump our ARP table. We're going to be able to get our IP address. We're going to be able to get the MAC addresses in there. Then we're going to resolve the MAC addresses using a REST API to the vendor of the different devices. Again, the command that this is basically being built on is something called arp.a. So arp is Address Resolution Protocol. It resolves IP addresses to MAC addresses. Remember, at the layer 2 level, the switch level, MAC addresses are what matters. And so IP address to MAC address. So these are any computers that your computer has seen. Doesn't necessarily mean any computer that's on your local area network. So whenever a computer communicates to the switch, right, basically, and it doesn't know where the device is, that will get blasted out all the ports on the switch. So any communication that your computer has seen, it will collect that information here. If a computer is silent for some reason, it hasn't been talking for whatever reason, or maybe there's already a route in the switch, so it doesn't need to get blasted out on all ports, that record might not be in here. That's also one reason that you might want to do a ping sweep. So basically, if you ping every IP address on your subnet, you will then communicate with every IP address on your subnet, so then you'll also have this information. But anyways, basically what we're doing here is we're just pulling the IP address and the MAC address, and then running it through a REST API. Subnet mask is the same as subnet. No. Well, sort of. People. You use words. Words have meaning. Words have meaning. 192.168.1.1 255.255.255.0. This is the subnet mask. The subnet mask tells you that this is the subnet. The subnet mask defines what the subnet is within the IP address. So if that's what you mean, correct. If not, you fail. You fail. Where am I at? Anyways. Oh. Okay. Maybe I should just do lectures. All right. Our little ARP tool. So import OS module. We're also going to import the request module. So the request module is used a lot. So install it into your Python environment, but it is not installed by default for whatever reason. So Python 3 -m pip install requests. So this does have to get installed into your environment or it won't work. Command is simply arp -a. That's just the command to get what I was showing you before. Response equals os.popen, that command, arp and a, and then we're going to read lines. So read method reads everything in the response as a string. Read lines reads each line into a value or an index value in a list. So the first thing that returned back will go to 0, 1, 2, 3, 4, and then we can simply loop it through it. So for x, that's kind of lazy. Anyways, for x in response. So for each index value in the response, I have these things here so you can kind of print out to see what's going on. So if there is a colon in x, right? Record then, so we're going to create a record. The record at index value 0 is going to be for your IP address. For an index 1 is going to be for your MAC address, and index 2 is going to be for your vendor. X value comes in. We're going to split based off of the blank spaces. So the reason we're looking for that colon here is if we look at the response, we might get things. See how this doesn't have any colon? So if there's a colon in the line, we want to deal with it. So this line has colons in it, so there's a MAC address. This line doesn't, right? There is no MAC address in this line, so we don't care about it, right? Again, if you scroll down, there's some other stuff, right? So basically, we only want to deal with any record that actually has a MAC address in it. That's why we're looking for that colon. We're then going to split based off of where the spaces are. Oh, let's see here. For y and x. So then for every, so x, so we're going to split. That's going to be a list for every value in the new thing that's been split. If there's a period in it, then y, we're going to replace the parentheses on either side with nothing. So basically what's going to happen is we're going to go through, we're going to, question mark is index 0, this is index 1, 2, 3, 4, 5, 6. So if there's a period, we want to grab that, and then what we're going to do is we're going to replace, we're going to get rid of the parenthesis on one side with nothing, and the parenthesis on the other side with nothing. And that's what we're going to be doing. Record 0, so that record that we created, index 0, is now going to equal that IP address. So that IP address that came in, that's now going to get plugged at record 0. If there's a colon in the value that came in, right? So colon, so 0, period, 2, okay, there's a colon. We're going to plug that into the value of record 1. So record at index 1 is then going to be y. We're then going to say try response underscore mac equals request.get, and this is going to be our REST API call. So to mac lookup app, and we're going to plug in that MAC address. So we're going to feed it that MAC address that we just got. It's going to come back as a JSON value. And then record 2, so 0 is IP address, 1 is MAC address, 2 is going to be vendor, equals response for the company. So if we get a company response back, that's going to get plugged in. If response company equals nothing, we're just simply going to say not in database, and except not found. So if this doesn't work for some reason, we're going to have it so it's not found. And that is what gets us that. So IP address at 0, MAC address at 1, vendor at 2. Again, not in database, so if we get a blank back, then it's not in the database for some reason, and if we get a not found, it means the REST API call failed for some reason. Does that make sense? Any questions? I got a koosh ball. I got a virtual koosh ball. I'll wing you with it. I swear I will. Okay, no questions there. We get to the final one. And God help me if I can explain this thing. On the up-down, I am getting a 500. Error. On the up-down. On the up-down. What do you mean on the up-down? You mean this? Oh, wait a minute. Which up-down? Well, if you're getting 500 error is a server error, which means it communicated with the server, but the server failed out for some reason. I'm not sure which up-down you're talking about now. We had a couple. We had a couple of ping things going on, so I'm not sure which one you're relating to. All right. More than happy to deal with it once we get to this final one, if I still have half a brain left. Oh, this one sucks. Okay, so basically what this one is again, so a table or a database, and I will delete it. So in my Eli folder, we have the ARP database, and I will move that to the trash. Okay, so what we're going to do here is we're going to run it. So we're running this. Okay, we go to 127.0.0.1, port 8080. So what this is going to do is it's going to dump our ARP table. It is going to then give us our IP address, our MAC address, and our vendor. But what we're also going to do is as we get new vendor information, we are then going to plug it. What is... Oh, you ever have the... Don't mind me. I'm simply losing my mind. I always find it funny when like noobs, they think they're going to get in technology so they can be so smart. Eli, all I've ever wanted is a job where I can prove how smart I am. Don't go into this field. Don't. Anyways, so this is the latest response. So we get the IP address, we get the MAC address, and from the REST API, we're going to fill in the vendor information. On top of that, what we're going to be doing is we're going to be dumping the information that we get into our database so that we can update more, right? So we can see here, 5C A72C has no vendor. We can see before we found out that it was Apple. So again, this is basically an exceedingly simple concept of something like machine learning. So let's go and take a look at this. So pretty simple for bottle. From bottle, import run from route, import OS, import requests, import SQLite 3. Command equals ARP space -a, database equals arp.db. Close up all of these. Okay, so we have the database create like we did before. This is simply for the table. Create table if it doesn't exist. We're going to create a table called ARP. First row is going to be MAC. Second row is going to be vendor. Then basically what happens is everything else here, again, is all functions. So as this goes through, we are going to call this function right before run. So when we start the script, it'll do that function. If the table doesn't exist, it'll create the table. If it already exists, it won't do anything else. Okay. And we go to index. Okay, so here, route decorator is root. Define this as index. Page, so this is the page that we're going to be creating. We started off with a table. So I started with the table. Response equals os.popen command, so arp space -a, and then we're going to read lines. For line in response, if there's a colon, we're going to say record is going to, so these are basically, we're creating a dictionary here. So for record, we're going to say there's going to be an IP value, there's going to be a MAC value, and there's going to be a vendor value. So a dictionary is basically like a named key array. So if there's colon, we're going to create the record. Line equals line.split, wherever there are spaces, for value in line. If there's a period in the value, we're going to get rid of the parentheses on either side. And then the record for IP is going to equal that value. So there's a period, we know it's an IP address, we strip off the parentheses, we dump that value in IP. If there's a colon in the value as we go through, that's going to be our MAC address. So that value is going to be assigned to the dictionary for MAC address. Then we're going to come down here for the try, response, MAC, request.get, again, API lookup. We're going to do record MAC. So basically, we're going to plug in that MAC address that came in. So we assigned MAC address here. We're going to plug that in. We're going to bring it back as a JSON value. Record vendor is going to equal the company name that came back for the JSON. If the company, the MAC response company equals nothing, record vendor equals nothing. Okay, pretty simple. Except, so there's a problem, vendor equals nothing. We're going to come down here, page, again, F string, so whatever we created in the page before, table row, record IP address, TD, so it's table row, table data, the IP address, table data, the MAC address, table data, the vendor, we close the table row, and that goes through, and that basically creates a table for us. Response underscore query equals db find record MAC. So basically, what we're going to be looking for is there already a record for the MAC address? If none, or if the response equals nothing, we're going to insert the vendor information. So basically, if we go up, db find, so this is for a single. So we're going to connect to the database. We're going to try, query, execute, select all from ARP, where MAC So the MAC address equals that MAC value coming in. We're going to fetch one. We're going to print the query out just so we can do troubleshooting. And then basically we're going to return the query. So basically we're going to say, hey, do we have a record for MAC address? And if we do, we're going to return it. When we return it, right? So if response to query equals none. So if there's no value for that MAC address in the table, or response query 1. So basically, when that response comes back, 0 will be MAC address, 1 will be for the vendor. So if vendor equals nothing, then we're going to go to DB insert record MAC, so MAC and vendor. And then we come up here to insert. And basically, again, we connect. And then we do update, set vendor to question mark where MAC equals question mark, vendor MAC. If the row count is 0, insert into ARP MAC vendor, values MAC and vendor. Else there's a problem, and then you just do that. That finishes out. So basically that creates the value in the table if necessary. It either updates or it creates. Oh, and then we come down here. So page, after we've created all of this, we're going to close the table. Oh, then we're going to come down here. So this is going to be for everything up at top. This is going to be for all of this. Then we're going to come down here. So response all equals database find all. So what do we want to do is we want to find all the values that are already in the database. So with this, query equals select all from ARP, query equals query.fetch all. So we're going to select all from ARP, and we grab all of those records and we return it. Let's see here. And then basically we're going to go through and for record in response all. So we get all the responses back. For each record, we have the table DB. So table DB, we open with a table, and then we create a row, then record 0, so MAC address, and then vendor. And then we go through, and then we close. And then down here, the page is going to be latest response with that original page, database records with that new database table that we created, and then we're going to return it. Oh, God help me. That's what gives us that. Now I'm going to go have a beer. Now I'm going to go have a beer. I do need to clean up the code. To be clear, as I sit here talking about the code, I do need to clean up the code. I will say that. I need to think about how I teach you folks this code, especially for DIY projects, a little bit more. But on the other hand, it kind of is what it is. It's also pretty close to where it should be. But again, so basically this is kind of showing you again how to auto-populate a table to bring in that additional information and show you what's going on. So again, so with this, you got Python, you got Bottle, you got SQL, you got a REST API, got some HTML in there. No CSS. I don't think there's any CSS in there. But kind of bringing it all in. But this is basically, this is how you build larger and larger apps. Again, the important thing to understand is like, you know, you look at something like Facebook, and everybody is always like, I want to build the next Facebook. Again, no, you don't. Just stop. No, you don't. But if you are going to be building larger apps, one of the things you have to understand is basically what you do is each one of these functions, think of this as a component. So you're not building the whole thing. You're building each one of these little components, and then you're basically just duct taping the things together to finish out the platform that you're doing. And that's the other reason why whiteboards are so important. And again, like if we were on a team, like that's the other thing. I'm just talking to a camera. Again, to me, I'm just talking to a camera here. It's kind of hard doing this. Like if we were building out some kind of whatever software, we would sit there for a week or two sketching everything out on a whiteboard so that we logically understand what the hell is supposed to happen, so that when somebody sits here and shows us the code, as we walk in the door, we're already drinking our cup of coffee. We already know basically how this damn thing is supposed to work and go from there. So that's why the whiteboards and all that kind of stuff matter. So anyways, that is the crap. It is 4 o'clock. It is 4 o'clock. So I'm going to stick around for a while. This took quite a bit longer than I thought to actually teach. I thought this was going to be about an hour to explain. I was wrong. So I will stick around for about a half an hour for you folks. If you want to tippy-tap type, I will take the questions about this, or Jock. If you have questions about turning an Xbox into a server, I can't talk about turning an Xbox into a server. It's not going to work. Spoiler, it's not going to work. But I can explain to you why. But if you've got any other questions, more than happy to answer whatever questions you got. And also, too, again, these labs, the lab book, if you go to Silicon Dojo, if you go to github.com/Silicon Dojo/online classes, right? This is where all our documentation is, right? So just, right? Then you go to coding DIY, you go here, and then you can click on the PDF, and this will give you what you're supposed to, again, all the code that you're supposed to put in. And again, I'm not joking about the single quotation marks, the quotation mark things. It just becomes, two things. One, it becomes muscle memory that you remember to do it. And then two, it becomes muscle memory to, if you get an error, you start to understand where those errors are coming from, right? So if something's not showing up on a screen, like this, where's my colors? Right, so yeah, I think this was the problem I did. Right, so literally, I forgot a double quotation mark. Right, so I run this. Right, so it's running. Oh, then I do CNN.com, Fox.com. Right. And so this is what I was getting. Right, look at this. This is really. Look at all this code. I've got like, how many lines of code? I got 66 lines of code. What the hell is going on? And what you'll also notice is I'm not getting any errors. Not getting any errors. So however I did that, right? So I deleted that. But you notice all the colors look right. Right? The F is blue, bracket is yellow, variable value is white. I'm not getting any errors. But my app is a piece of crap. And so, again, one of the skills that you learn is to go, I wonder what's going on here. You go to page source, and this will show you the source. And then you go through here and you start looking. And you're like, okay, style equals background, double quote. And then here you can see, oh, wait a minute. Right? You have something weird going on with this. And you're like, oh, I wonder if that's the problem. Right, anyways, that's part of the troubleshooting thing that you learn. Anywho. Oh, Jock, I saw you. Jock. Put your hand up again, Jock. There you go. Jock, what's up?
Hey, thank you. Yeah, I gotta scoop my brain back into my head to get through this stuff for the next 2 weeks. So just luckily, like I have someone to help me with some of this sometimes. So if we come across something like I'll give you an example, like for the REST API, that lab, for me to get the code to work, I had to actually put in my IP address to actually work in the code, but I got it to work. For some of these labs, will we be able to reach out to you on Meetup to like troubleshoot a little bit, or we just try to figure out the best way we can? That's the first question.
What is the answer to that particular question? Yeah.
Or is the answers in our past labs kind of sort of?
Yeah, if you want to reach out to me on Meetup, the problem, I just got a lot of stuff, and my brain doesn't. Honestly, my brain does not work well with most online communication. You don't know how many emails end up going in the trash can just simply because I look at them for 2 months and then like, oh well, click. So yeah, you can get in touch with me at Meetup or LinkedIn. Honestly, I recommend the whole LinkedIn thing, and I'll try to help you a little bit. Again, one of the reasons I try to do these classes in person initially for like a year and a half is just because it is so much easier to troubleshoot, especially if everybody's on the same types of systems. And so, yeah, if you reach out to me on LinkedIn or Meetup, I will try to help you some, but I will admit the amount that I'll be able to help you is probably relatively limited.
That's helpful. And so, second question, we're not exactly stacking all of these together. We're just doing one at a time to try to see if it's slowly working and build it upon there, correct?
What, with these particular projects?
Yeah.
Well, it depends what you're...
Because in the one, you got 133 lines of code. We're not stacking these on the other to try to get it to run like one big system, correct?
Yeah, no. So these aren't one big set. These are all individual projects. As far as within them with these different functions, it kind of depends on how each one was built. Again, like the pink sweep is the pink sweep. You just do that one. This is the most complicated one. So again, you have one function talking to another function, talking to a REST API call. So much of this has to be finished for it to work at all.
Okay.
Yeah.
All right. If no one else has a question, I'm like, if you want to ask the Xbox thing, that's fine. If not, I mean, someone kind of answered the drivers and component software, but yeah, it was just a dumb idea that when you were explaining it, I was just thinking, so, but never mind.
Yeah, well, no, actually, it is interesting. So it wasn't Xbox, it was actually PlayStation 3s. So when PlayStation 3s came out, one of the interesting things with it is that Sony really did actually subsidize the hardware. The idea was like Sony paid $500 for you to buy a PlayStation 3 for $400. And so people realized that they could buy better computers and basically have Sony pay for a chunk of it. And so there was like a year or so there where there was this whole thing about building a cluster, like the Air Force. The Air Force, I do believe, actually built like a cluster of freaking PlayStation 3s to do something. What happened though is those aren't open systems. It's a lot like your iPhone. So although it's like a Windows computer is a computer, your iPhone's also a computer. This thing is locked down, that isn't. And so that's the issue is with the Xboxes, with the PlayStations, the resources are there, but they literally lock down the firmware, they lock down the software, the operating system so that you can't turn it into a server anymore. So that's the big issue there. What kind of dynamic data can we use in projects like these away from networking? Can we use real inputs data locally? How real projects get tested before going online? How do real projects get tested before going online? Yeah, that's a question. Oh, what was that company that caused like $500 billion in damage recently? Again, you can do import random. Let's see here. Num equals random dot randint 0 through 9. Print num test their desktop. So you can do like random. Again, this will get you spastic all over the board again. Like, so it'll give you a random number between 0 to 9. Like if I run this, right? Oh, stop running that. If I run this, gives me 2, gives me 7, gives me 8, right? So you could say, if num greater than 5, print hello. Oops. Else print goodbye. All right, so I run this. Says 2 goodbye. Run this again. 2 goodbye. 2 goodbye. 0 goodbye. 0 goodbye. 2 goodbye. 7 hello. 5 goodbye. 9 hello. All right, so again, you could just simply do a random number. Or what you could do is instead of that, you could do num equals the input function. So we've used this a lot in classes. Give me a number. Let's just make sure that should be work. So number, give me a number. So when I run this, it says give me a number. I say 7. Yeah. It thinks it's a string. So we do int number. Give me a number. 5. Enter. 5. Goodbye. Give me a number. 9. Hello. All right. So you could do the input function. So again, do remember if you use the input function, the data type that comes in, auto-assigned in Python, auto-assigned a string. You can't compare a string to an int, right? So anyways, you got to turn it to an int. So this gives me the value. This turns it into an int. This assigns it to there. So you could do this to give yourself something to plug in. Or again, you could do random. The other thing too, again, I've shown you folks before, is if you tab that out and we do a while true. So a while true loop just keeps going. And I put that in there. All right, so I run, oops. So I run this. All right, so give me a number 3, enter. Goodbye, give me a number 9, enter. Hello, give me a number 2, enter. Goodbye, give me a number 10. Hello, right, so that loops through. So this is a good way too, like if you're trying to figure out exactly how like sensor values will work, again, you could put this in so you could manually send it values and see what the hell happens before you have it auto doing whatever it's supposed to do. So yeah, I mean, those are some things. Again, there's lots of data. You could have a list. You can go to ChatGPT. Again, go to ChatGPT and like ask it for a list of 1,000 temperature values. Like give us some kind of like weird like, give me a list of temperature values in a nuclear facility that would be, melting down 1,000, right? It might actually get, and so that might be interesting if you could pull that out of something like ChatGPT. You actually plug it in, and then you could run off that list. Again, a 4x loop for the first value, for the second value. If you actually have that sensor curve, you could see when your systems start triggering events to occur. Like you can do things like that. Lots of ways to dump data in there. Just got to figure it out. Yeah. Couldn't there still be a possibility to turn the original Xbox into a server using homebrew tools? I'm not too familiar with it, but what I read online seems to suggest its security was broken enough to be able to install and run Linux. I mean, wow. Can I run an original Xbox? I don't know. Again, with a lot of this stuff, it's just like what's... A lot of what we were able to do as technology professionals is literally based around how these things are designed, right? Again, that's the whole thing like with Louis Rossmann, right? Frenemy of the show, Louis Rossmann. He keeps complaining. Like he technically knows how to repair many pieces of Mac equipment, but he is literally no longer able to buy the components so that he can swap them out, right? That's the same kind of thing with a lot of this stuff. Like as a system administrator or whatever, there's a difference between technically understanding what's going on and actually being able to do it. And then you also have to think, is it worth, doesn't matter. I mean, how old is an Xbox at this point? What, an Xbox is 20 years old, right? An Xbox 360. I don't know, I've been an Xbox person. But again, you have PlayStation 2, PlayStation 3, PlayStation 4, PlayStation 5. We're about to have PlayStation 5 Pro. And basically you're saying, hey, why don't you go back and use that 1999 game console as a Linux computer? Again, technically, possible. I wouldn't want to do it. Yes, just because you can doesn't mean you should, for good reason. Yeah, I mean, that's the whole... again, it's whatever interests you. Again, you have a lot of people, again, retro gamers. They like the retro technology. I was there the first time. What I think is funny, I understand records. I'm not a fan of records. Again, I was there the first time. I'm not a fan of records, but I understand the concept of why some people like records. Playing records, playing LPs, there is a difference. There is a life to an LP that does not exist for MP3s or whatever else. But what I do not understand now is apparently the youngsters like cassette tapes. There's no value to a cassette tape. Cassette tapes are garbage. The only reason a cassette tape was useful was because it was actually portable back in the 80s and 90s. That was it. I listened to one of my old cassettes 10 years ago, and then I threw the entire pile into the garbage because the quality was so bad. I think that's funny. A lot of the kids nowadays, cassette tapes apparently are a cool thing. I'm like, no. And that's where, putting Linux on an Xbox. Can you? You can also buy a Raspberry Pi 4. Okay, Abdul. You're a little late, Abdul. Abdul, welcome to the class. That's over. That's well over. Abdul, yes, I just came into class. Could you tell me what you've said so far? No, Abdul. Nope. Class started at 2 o'clock. But happy to have you. Don't worry. You will never fail a Silicon Dojo class because we don't have grades. Thanks for the projects. No problem. Try to clean them up in the future. Again, the only thing worse than a procrastinating student is a procrastinating teacher. I was literally creating a couple of these things before class today. Oh. Because that's the weird part. It's figuring out things educationally. You know how I would design things for a buddy. If a buddy, your client came to me, you know how you would do it. But it's how do you rip out enough so there's not too much for students, but keep in enough that it's actually valuable? Okay, can we put localhost /cnn.com and rm star? No, because it won't matter. So this guy's trying to be funny. He's trying to be funny and do an injection attack. I hope it doesn't work. Okay, so what he's saying with a injection attack, right? So we do 127.0.0.1, 8080. So this is the initial. This is the first project we did with a dynamic filter with one. So what he says is, could I do space RM star? So what he's trying to do here is he's trying to add an operating system command, and the operating system command is to remove everything. Well, that's one of the nice things with Python, is in this, we do have OS. Anyways. It's not going to work. Anyways, one of the nice things with Python is unless you add the module, it's not going to do anything. We actually do have an OS module, but it's still not going to do anything. Because basically I hit enter there, and what happens is with the browser, it actually thinks I'm searching for something. I don't think, if we do Google. Google. It's actually kind of funny. Yeah, it might be first layer of defense. It's your stupid web browser. What? What are you doing, Google? Come on, Google. Control V. Oh, yeah. So this doesn't go to search with CNN.com, blah, 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 could not resolve. And what you'll notice here, it plugs in by default the percentage 20, percentage 20. So it's not even spaces, it's, is it ASCII? Anyways, it's the code for spaces. So basically it's saying that it can't resolve can't resolve it. It thinks it's a host name. Yep. If we put localhost, yeah, no, it does that for you, and it doesn't do anything. I don't know what. Could you? I don't know. So basically, the idea with the injection is you'd want to somehow exit it out and then run another command. But that's not how like os.popen works. Like that's the thing is with SQL, right? So the semicolon is considered the delimiter. So when you run it, it'll run that first bit that gets chucked because it's worthless. It'll run your actual command, and then it'll run the final bit that gets chucked because it's worthless. So based off of those semicolons, it tries to run all of that. With the operating system, is there a command delimiter that you could try to plug in? Because enter, return, could you do a return? I don't know. Do we have any actual cybersecurity experts out there? Because that's basically what you'd want. How the injection attack works is basically you kill the initial command and you dump your command in there. So in order to be able to do that, you need to have that delimiter. And I just don't know I don't know an operating system delimiter that would do that. I am thinking, is this script safe to put on the server? No. Well, I'm not sure it's hell no. Is this safe to put on the server? I mean, ish. Depends on what your vector of attack is. One thing, remember with bottle. So, go away, Google. So bottle is the web app framework. So again, if you're really putting this on a real server, so you have your Python script. So you have your app, right, with bottle and Python. Right, and as we said before, this is running on port 8080. And actually, when this goes into production, it most likely will be on port 8082. Because what you do is in front of this thing, you put Nginx. Nginx. So what Nginx is, it's a web server. It's like Apache or IIS, so it still exists. But the other thing that it does is reverse proxies. Reverse proxy is kind of a cool thing, but one of the big things with reverse proxy is it figures out resource consumption, it optimizes traffic and all that kind of stuff. And so basically when you have somebody coming from the outside world, so let's say you have crappy app.com, and that resolves to 155.66.44.1, right? So Nginx will be 155.66.44.1. So when somebody goes to crappyapp.com, they would come into Nginx. They would see that you're trying to go to the ping app. Nginx would do a lot of optimizations for you and then send to your app at 8080. The results would come out, and then they would go back to the user on the cloud. So the first thing is that you would put Nginx in front of this damn thing. The next things that you might think about, again, if you're going to put this in production, is some kind of rate limiter. So pull the IP address. So whenever anybody connects to your systems, you'll be able to pull what their IP address is. So you might limit, so they can only do like one request per second or whatever. Because I mean, they could set this up almost like a REST API call and just, you know, essentially try to use your server as a weird thing of death. I don't think it would work against anything, but they could be a pain in the ass about it. Again, especially if you got a small instance, right? If you went to Linode and you paid whatever it was, you know, $3 a month for whatever they gave you, they might be able to overload a crappy little bottle app if that was just wide open on the internet. Yeah, there are some things. So, and that's where you have to think about, like with architecture. Again, talk about architecture. Architecture. It's like, yes, Eli, we've heard about architecture. Shut the fuck up about architecture. But it really doesn't matter. It really doesn't matter, right? If your box is sitting on the internet, then you really have to worry about cybersecurity. Cybersecurity really matters, right? On the other hand, I mean, if you have a box in your infrastructure and it's only accessible from your infrastructure, again, lock down the security privileges. Make sure nobody has a global admin account to the damn thing. But otherwise, I mean, again, you don't need quite so much security because you literally have a router. You have a separation between you and the outside world. So again, should be relatively secure. On the other hand, right, you know, if you just have your little computer and you're the only one that accesses it, and again, you set up a firewall, maybe you set up a firewall so nobody else can access it, then I don't know, how much security do you really need, right? I mean, if you set up a firewall, so if you have Linux, UFW, whatever else, and you basically say, on port 8080, the only connection allowed is from 127.0.0.1. So basically your firewall blocks anything coming to port 8080 over any IP address other than your loopback. I don't know. How much security do you need there? And again, that's the kind of thing you really need to be thinking about with this whole idea of, again, like what is production? You know, what is, deploying into an environment? What does that actually mean? Because again, the big problem that I see is with a lot of noobs, they build security like they're putting this damn thing out on the web, and that's its own, right? That's its own resource consumption and everything else, right? You have this nice little crappy app that does exactly what you need it to do, and then you spend the next 3 months designing a security structure around it. I don't know, kind of stuff you have to think about. What is the difference between 0.0.0.0 and 127.0.0.1? 0.0.0.0 is any IP network interface on the system. So you have your box. So normally you have one port. You have your computer and you have one port, 192.168.1.1, whatever. 127.0.0.1 loops back to that one port. You could theoretically have a lot of ports. Again, if you had a server, there's something called NIC teaming. At least it used to be called NIC bonding. Anyways, the idea is that you can have numerous network cards on one server to deal with traffic in different ways. Again, architecture. So with this, you can either plug in the specific IP address. So I can plug in 192.168.1.1, and so it will only respond to traffic on 192.168.1.1. If you do 0.0.0, it will respond to traffic on any of the ports. Now here's an interesting question. What actually is a loopback address? How is the loopback address different than 0.0.0.0? If I plug in 0.0.0.0 here, 127.0.0.1 will work. Oh, interesting. Oh, maybe that's where I'm being stupid. Maybe that's where I'm being stupid. If I'm being dumb. No, I'm not being dumb. Yeah, so let me see something. So my IP address, stop it. My IP address here is .4. Hold on one second. 192.168.1.4:8080. Anyway, so this computer does not accept it. Let me try this. Trash it. May have a firewall set up. Anyways. So when I say 127.0.0.1 for my bottle app, it should only respond to the loopback address. So if I plug in 127.0.0.1, it will respond 127.0.0.1. If I put in 0.0.0.0, then anybody who is able to access any of my IP addresses should be able to get to the bottle app. So I could put in, like I said, I could put in 192.168.1.1 or 1.4, let's say. If that's my IP address, then only people trying to access that should get into my bottle app. Do believe that is correct. Oh, there we go. Yay! Yeah, you can't see it. Okay, see this right here? Yeah. See, before, when I had 127.0.0.1, and this computer here, I tried to connect, it failed outright. You can see here, 192.168.1.15, that's this computer was able to connect. So 0.0.0.0 means any IP address that this thing has will be accessible. Mommy, can I drink a beer now? God. Oh, let's see here. Can you explain some of the things that would make it unsafe to put on a server? Like these apps? Basically, you have to think about like what an attack looks like and what you care about. So, I don't know. I mean, if you had your server locked down and you had Nginx, I mean, this is pretty secure to a degree. But again, this could get hit with a denial of service attack. Remember, all denial of service is essentially using so many resources, the system can no longer respond. So again, if you put this on a little $3 Linode box, and then other people realize that it exists, and they essentially start hammering the hell out of it with REST API calls, you could essentially get a denial of service attack from it itself. You could get issues, again, if you don't have any kind of security on this at all. Again, people using REST API calls, they could create their own Python scripts to go through your box in order to try to do mapping that they're trying to map, ping different things. Again, remember how logging works, right? Logging goes back to the system that was trying to do something. So basically, if they're on their computer, they send a call to your computer, that ping goes out against the target. the target, if they have a log file, they'll show that you were pinging them. That might cause you like some issues. That's one thing for you to really be thinking about, especially with my viewers. One of the real problems we have, especially in the global community, like with YouTube or online stuff, everybody apparently thinks the Constitution, has anything to do with them. Again, like in the United States, right? We have inalienable rights, sort of. But anyways, one of the interesting things is you get a lot of people in other countries that they kind of get the idea that their country works the same way our country does. And what I try to explain to people is, again, like if I was in the security services in another country, right? I don't have to break your password. I just have to break enough of your fingers for you to give me the password. It's like, oh, hee ha ha. And it really is true, right? And so one of the concerns here, again, if you're in another country like Lebanon right now, Thailand goes up and down. Anyways, I don't want to get into trouble. If you're in Zimbabwe, we just use Zimbabwe. Zimbabweans just like to be remembered. Anyways, if you're in Zimbabwe, and let's say there's a election going on, right? Elections just doing what elections are doing. But let's say one side of the election tries to do a distributed denial of service attack against the other side of the election, right? Well, especially if you're in that country, if you are a Zimbabwean and somebody sees that this is open and they use that as an attack against, who they're going after, these people look at the log files, all they see is that your server attacked their server, and, you may get some very unpleasant lessons about the criminal justice system in that particular country. And so, like I said, that's the kind of stuff that you just kind of have to think about. You have to think about like with your particular situation. Again, I don't know. Should be fine. Should be fine. I don't understand the analogy of that with machine learning. Oh, basically just the idea that your box is learning. Your computer learns. Again, remember, whenever anybody talks about anything, I always talk about big levels, big, complicated things. A lot of stuff is simple. Again, there's a real question. There's a real question with the whole thing with AI is, what is AI and what is a really complicated if-else statement? And again, one of the questions that could be asked, what is AI and what is just an insanely massive database table? And so all I was trying to show you here is basically your machine is learning. All right, so, so you have your system, right? You have your system, right? And the thing is, it's going out and it's talking to the world. Now, how this system that we have is talking to the world is through a REST API call. Right? It can be talking many different ways. And so basically it has questions. When you think about the MAC address, what is it really? What is the nut meat of a MAC address? Really, for what we're talking about, a MAC address is just simply a question. What is this? Right? So for us, we're looking for a vendor. Apple or Netgear or whatever else. And so basically what happens is every time we go out and do the REST thing, basically a couple more things get filled. And then we go out and do another REST thing. And then, Microsoft or Cisco, a couple more things get filled. And they go off and do another REST thing, a couple more things get filled. And one of the things to be thinking about, like when you start correlating data, like with databases, right? So currently we're just going to this one REST API. So this one REST API just happens to be quirky. Sometimes it gives you data, sometimes it doesn't, right? So basically we're just using this table as more or less a caching and a data store mechanism so that every time we do get a value that we want, we keep it. But again, imagine if there's numerous different ways to get input. So let's say we go to this REST API to try to fill in the blanks. And if we don't get the blanks from there, let's say there's another REST API that will be able to fill in the blanks. And then let's say if those don't work, then down here, we basically have a person. We have people that go out, our little tech professionals, and they start filling in the blanks. And basically, in a very, very simple, again, I'm not trying to make this any more than it is, not trying to make more than it is, very simple. Basically what you have is you have a system for your little device to start learning, to start answering the questions that it has. And I think if more people started looking at some of this AI stuff, more like this, more as how can we use digital systems to continuously answer questions, I think we get into some more interesting stuff than basically what we have with AI right now. Again, like with a lot of AI, right, with ChatGPT or Claude, again, fancy crap, way over my head, way over my pay grade. But think about what is the actual solution that's coming out of a lot of this stuff. We're getting incredibly technical, resource-intensive garbage, right? Think about it. So much of what they talk about AI right now is essentially how can students cheat on their term papers, right? And you go, oh, haha, but you think about it, and it's also how can marketing people cheat on their term papers? And how can CEOs cheat on their term papers? If you look at a lot of the resource consumption for AI, it's about basically people cheating on their jobs, which is its own question. Again, I think one of the more interesting things is thinking about, again, actually trying to solve problems. And when you start solving problems, do I need an LLM to speak to me in Shakespearean? Or do I just need some, blanks filled in my database? So anyways, simple concept with learning. Okay. So anyways, there we go. It is 4:41. I have not had no questions on the actual projects themselves. Hope some of you guys do it. Or girls, or others, whoever's out there. So we are going to have another class Friday. Once I grab a cup of coffee and sit down, I'll put it up on Meetup. So we're going to have a class on OpenCV. So OpenCV is a computer vision framework that you can use with Python. I've done classes and stuff on that before. We should have that on Friday. And again, I'm just going through, trying to create these classes. Whew. Lots of work. Lots of work to create classes. Again, videos will be up on YouTube. Should be up tomorrow. This class will be up on YouTube tomorrow. The other classes have been there. Any of the class information, again, is on GitHub. You can connect to me on LinkedIn. And that's all I got. If you've got no more questions, I'm going to call it a day. Any questions? Any questions? No? Cool. See y'all later.